Well, welcome everyone to our webinar series for this month. Our topic today is 5 ways to maximize your MCAS investment. MCAS, of course, being an acronym for Microsoft Cloud App Security. And we'll go ahead and get started. From quick agenda, just 4 main points. Give a little background on OCG, Oxford Computer Group, and who we are. Then we'll talk a little bit about MCAS itself, an overview for those who may not be familiar with this offering from Microsoft and what it does. Talk about the current threat landscape and how MCAS can help protect against those. And then the 5 ways, these are 5 ways that I chose that I thought were important that can help customers who have either bought into the Microsoft 365 E5 licensing, so they have a lot of these products and capabilities already as part of their entitlements, but may not know where to get started. The genesis for this webinar was really me thinking about past customers who were in that scenario. They had purchased E5, they wanted to invest in the Microsoft security stack and into the suite because of the promise of great integration, shoring up gaps in visibility and security, but you just ran into that scenario where it was another tool, it was somewhat confusing, another portal, and their analysts were sort of struggling with the alert noise and didn't know where to go from there. So hopefully these 5 points, and I did it in this format because I like lists, was a fan of the David Letterman top 10 back in the day. It was just sort of a good way to show priority, and the way I do have them listed is from a easy to implement to some of the more advanced features. So Oxford Computer Group, been around for 18 plus years, mainly working with Microsoft Identity. We are a Microsoft Gold partner, and Microsoft is our biggest partner that we work with. And again, we're very focused on identity and security. And we help our customers do everything from implement identity lifecycle management in their environments, clean up legacy identity lifecycle management integrations that have been done in the past, help with securing their identities using the Microsoft tool set, and also with identity governance applications with our other partner, Savient. So quick overview on Cloud App Security, again, for those who are not familiar. It's a Cloud App Security is a CASB solution. CASB, a Cloud Access Security Broker. This is a type of product that's been around for some time now. There are other vendors, of course, who make Cloud Access Security Brokers, like Netscope, Symantec has its own, and there are a bevy of others. So Microsoft got into the Cloud App Security Broker area back in 2015 with the acquisition of a company called Adallom, an Israeli company, and since then has been leveraging the CASB as a way to answer the shift in the way we do security. Of course, the old traditional model was all your apps were on-prem, all your apps and your endpoints were behind a firewall, even with users, mobile users connecting via VPNs, still behind the firewall. And so you had control over your applications and how they were being accessed. And of course, with the advent of cloud, many customers moving to the cloud, and for all the right reasons. Cloud offers a lot of benefits. Now those applications were being controlled by third parties. Of course, you manage your authentication, your authorization to those applications, but now you had to start tracking down who's using what application, how are they using it, is it authorized, is it a sanctioned application, what's going into that application, is it holding data, etc. So a CASB provides that visibility, and Cloud App Security as a CASB is a uniquely integrated CASB solution because it is part of that Microsoft security posture that helps customers really get visibility into their SaaS applications in an environment, and provide things like session control tied to the data loss prevention engine running within Microsoft. Helps customers create policies and rules around data flows, where data is stored, et cetera. And there's a lot of other, of course, capabilities. And it's essentially rooted in supporting any app. I've been to customers who, again, deployed Cloud App Security, but they only have Office 365 connected, but they have a bevy of other third-party applications like ServiceNow, like AWS, Slack, Workday, but they're not leveraging the capabilities within Cloud App Security in order to gain visibility and governance of those applications. Some of the top CASB use cases, starting from the left side, has been really just that shadow IT discovery, right? Being able to look in the environment and see where users, groups of users, departments have adopted a cloud app, a SaaS app, for their own use. They didn't want to have to deal with IT. They didn't want to have to go through the whole process of filling out forms and going through perhaps a change management. And so someone had a credit card, someone gave them an authorization to go out there and get a Box account. Or they were working on a project with a very important customer, and that customer wanted to use Box because that's what they were comfortable with. So that's what your internal users started using. Cloud App Security, one of the use cases, of course, is doing that shadow IT discovery. Being able to govern those discovered apps, to be able to mark them as sanctioned or unsanctioned. So now you can start having some control over where those applications are being used. It's not to necessarily block those applications, because if they have legitimate use, you want users to be productive, and there could be a good reason, but now you want that visibility. And there may be other applications that really shouldn't be used in the environment. They've got very low risks or high risk scores. They've been breached in the past. So you want to be able to set up some policies around that. And then, of course, there's the cloud threats that are out there that are constantly evolving, that you want to be able to have policy control over as well. And Cloud App Security is one of the, in terms of a threat defense mechanism, is able to do that, for various scenarios. There's, of course, the malicious insider, right, protecting against that disgruntled employee who is perhaps exfiltrating a bunch of data from the environment because they've been told that their performance is bad and they're going to be terminated. So they try to either leave the company with proprietary information, some company IP. There's, of course, malware, constantly protecting against malware. So Cloud App Security is able to detect that malware in the cloud and those cloud storage locations as soon as it's uploaded. Ransomware detection is part of its technology, identifying that ransomware using advanced behavioral analytics, being able to identify rogue applications. And I mentioned that data exfiltration issue, and also where accounts may have been compromised because of the signals that Cloud App Security is getting from other sources, such as the Microsoft Graph and the Microsoft Intelligent Security Graph. Some of the more recent threats that we're seeing, OAuth application threats. So OAuth, of course, is ubiquitous. Many applications have used that as their authorization model for applications, and alongside with OpenID Connect as an authentication protocol to both grant access to an application and the data within that application. So because of that, threat actors have evolved that very useful capability now into a way to infiltrate an environment. So shown here by the diagram, an attacker will register a malicious app with an OAuth 2 provider, and then they'll start sending out email-based phishing, and this is consent phishing. So you may have seen those prompts if you authorize an application to grant it read-only access to your calendar, for instance, or to your contacts, and let's say your Gmail account. Well, imagine if that was a phony app that was doing that, and now it had read-only access to all your contact information. Even though it's read-only, it's still bad enough, right? They can get access to sensitive data. They can start combing through contact information, email addresses, and then further deploy tools, deploy email-based phishing scams to try to now get users to click on those links to further grant them access. So that's one of the threats that we're seeing, and we'll talk about how MCAS can help protect against that. And just furthering that point on OAuth application threats, the genesis of that is that OAuth application already has a permission, so there's no need to get them. Again, you've granted them access to that if you're fooled by that phony OAuth app. If they need additional permissions, it may just seem legit and people will just grant them access. A lot of times we get those prompts, we're not reading exactly what it says, and users are just clicking away and granting further access to an application. Because the user is already authenticated, their MFA does not factor in. They've already granted that authentication, so they're not going to be challenged further. And it might be difficult to identify malicious activity from common OAuth applications. That type of access, read-only access, will just seem legit without peering into it closer. And of course, those activities can easily and be broadly performed with the app's regular APIs. So we'll take a look at some of the things that we can do. And the first one, so number 5 on the list, is to integrate. And what's meant by that is turning on all the areas within the Microsoft 365 Defender suite of products where you can integrate with Cloud App Security. The benefits of that, of course, is you get a unified SOC experience for M365 Defender for all workloads. Now, this is assuming, for those listening, that you have Microsoft 365, that's an E5 license. And so you do have all the capabilities. You have Defender for Office 365. You have Defender for Identity, previously known as Azure Advanced Threat Protection. All the ATP products are now the Defender products. You have Defender for Endpoint that you've deployed. And so you want to be able to have that unified experience. So integrating MCAS with those other workloads is going to be the best way to do that. Now, I just took some screenshots. So this is from the Defender Security Center. So this is for Defender for Endpoint. If you go to Defender for Endpoint at securitycenter.windows.com, go to advanced features, you'll notice that there's an integration for Defender for Identity integration, but also a Microsoft Cloud App Security integration. All this means is that your Defender for Endpoint nodes will now be able to send alert information signals to Cloud App Security to give administrators, give those analysts that deeper visibility into, sanctioned apps, unsanctioned apps that are being run on that endpoint. Within Cloud App Security itself, if you go to the settings area, you have 3 areas to integrate. You can integrate with that Defender for Identity. So this is your on-prem solution. Again, previously known as Advanced Threat Analytics when it was first incorporated into the Microsoft security ecosystem. Again, back in 2015, that evolved into Azure Advanced Threat Protection. Now it's Defender for Identity. That's where you have that hybrid look, right? So you want to see what's happening on-prem within Active Directory on your domain controllers. Well, if you turn on that integration, you're going to start receiving signals from Defender for Identity into Cloud App Security. Again, rolling up all those signals, getting that aggregate data, getting the correlation into those incidents, and not just have a bunch of alerts that may not make sense independently. You can also turn on integration for identity protection. So if you have identity protection enabled in your environment, and you should if you have the entitlement, you can turn on that integration so you can see where you may have risky sign-in, user sign-in risk, and again, get that correlation. A new, relatively new integration point is this app governance. So you notice it is marked there as preview, and in your environment, you'll likely see the same. But the app governance part of the integration, this is an add-on feature to Cloud App Security. And let me just move this to my other screen here. Yeah, it's an add-on feature to Cloud App Security, and it's a policy management capability that's designed for those OAuth-enabled apps that access Microsoft 365 data through the Microsoft Graph API. So if you have an app, a legitimate app that you've enabled, and you have using OAuth, have integrated into your Azure AD environment, app governance is going to deliver that full visibility, remediation, and governance into how those apps and the users access, use, and share your sensitive data that's stored in Microsoft 365. There is a capability right now. If you look at that, you can turn on a trial license for it. You do have to be an E5 or A5 if A5 for higher ed. You have to have that license in place or one of the other SKUs, but you can add this on and get that app governance. I wanted to call this out since it is there under the threat protection area for integrating within Cloud App Security. Another benefit of that integration is, so we're looking at just a screenshot from the security.microsoft.com. So this is your Defender for 365 console. Again, I mentioned it before, but you do get that all-up view of those alerts that are coming from different signals. So you may have an alert from identity protection. You may have an alert from Defender for Identity on-prem. You may have an alert from Cloud App Security, for instance, for a impossible travel type activity. And all those are rolled up into these incidents, and then you can start looking at the incidents because it'll aggregate and correlate that data for you so that you can get the full picture of the IOCs in your environment. And then there's the capability of being able to do the advanced hunting. So here again, this is within the Microsoft 365 Defender console at security.microsoft.com. You under the hunting node. On the left here, the Cloud App events. These are all of the events that are coming over from Cloud App Security. You see there now just highlight here, but the service source is Microsoft Cloud App Security, and it'll give you all that summarized view of those alerts from within. And soon there will be third-party integration here as well. So if you have those third-party apps, which we'll talk about next, tied into Cloud App Security, you'll get that visibility into those alerts. The fourth way to maximize your investment is to protect your apps. So to Microsoft and those using Cloud App Security, SaaS security is not just connecting specific applications and providing ad hoc security to those applications. Instead, it's more like a funnel. You have to gain that visibility first, right? So you can't protect what you can't see. And so discovery of those applications is on top. So we talked about before that discovering that shadow IT is one of the primary use cases for leveraging a CASB solution in your environment. Once you have that data exposed and you go this next step with connecting those apps via their APIs, you get even greater visibility. Now you can start doing things like governance of file violations, right? So you can set up policies around files in the environment that may be sitting in OneDrive, in SharePoint, in Box, Dropbox, in Slack, in S3 buckets. You get the posture visibility. So any misconfigurations will surface and you'll be able to see where you may need to make some adjustments. And you get that continuous threat detection by connecting those apps. And as of today, these are the 17 apps that you can connect directly in Cloud App Security. 3 of them are in preview. As you see there, the OneLogin, Slack, and Zendesk are still, they are in public preview, but public preview means that you can go out and use it. It's supported and should be GA soon enough. But notice all the other apps besides O365 that you can connect. And the word on the street is that by the end of the year, the goal is to have 30 total applications be available here for connection via the APIs. So the benefits, of course, of doing that, and one thing to bring out, let me back up just a second to this, because you may hear often talked about, MCAS can protect any application. And that is true by using the session proxy, and we'll talk about the session proxy in the next area for conditional access app protection policies. But these 17 applications here are the ones that you have full API connectivity with. So it involves, setting up some API connectivity to those applications, but now you get that full visibility into the applications. You get to see the data that is sitting in Slack, that is sitting in Salesforce and Box. Whereas with the session proxies, you can control that data in transit and set up policies around what can and cannot happen, block access, for instance, block download, block upload of applications, of data from those applications. These applications here, you just get more functionality out of that connectivity. I'm going to build this out here. So for those applications, the one you saw on the list of 17, for the most part, you're going to get the standard threat detection. That threat detection is ubiquitous across all those apps, and once you connect them, there's very little to know, or very little configuration that you have to do out of the box. And so if you haven't done so already, if you just have Office 365 today connected, but you do have any of those other applications, start taking a look at how you can connect them, and there'll be resources at the end where you can go to see how to do that. But your standard, protection against cloud threats, you're going to get that malware protection. So any malware that's implanted in those cloud apps, those malicious OAuth applications, the multiple failed attempts, those indicators of compromise, right? Activity coming from Tor nodes, dark web, anonymous IP addresses in countries that your users don't generally work in, right? You'll see all that visibility within those applications now. Same with that unusual file share activity, file deletion activity, exfiltration, ransomware, and also the malicious use of a privileged user, so someone impersonating a global admin or another privileged role within the environment. Of course, not all these things will apply. For instance, you see here that unusual multiple delete VM activity. That's not something that's going to apply within, say, Slack or Salesforce, but it will apply within AWS and Azure. And so those rules will be there that you can configure, enable, configure, and enhance according to your needs. So a couple of use cases. Actually, I have 3 use cases here. And we're going to use specifically non-Microsoft apps, because we know that with the O365 suite, there is that first-party integration. But this is just to further that point that MCAS works really well with these third-party applications. Slack, of course, is a very popular application, and many organizations are using it. Many organizations use it in tandem with Teams even. They may have, I worked with a customer who was running Slack and running Teams at the same time for different purposes. And so, of course, this is an application that you're going to want to connect and get visibility into. Slack, just like with Teams, is often being used to transfer critical IP within the environment. And so it can be a prime target for attackers. So one use case is, for instance, Slack allows the creating of public shared links. And so MCAS can detect when those links are created and just surface an alert, right? It may not necessarily do anything to stop it, unless that is something that's been configured within the application itself. But for the most part, out of the box, Slack can provide or grant that access to create those public shared links. Now, someone creating that public shared link is one thing, but if you also want to see when that link has been accessed, MCAS can provide that visibility as shown here. When those links are used, that the Slack user account will be listed in the activity log as the actor, and you can now see when those links have been used. Same for, or another use case is permission monitoring. So within Slack, you set up certain permissions within the environment as a baseline, and you want to make sure that those are not being altered, because you don't want someone to, change the permission level of a user that may have just been granted guest user access to an account and now may be given owner access. So again, by connecting connecting Slack via that API connector, you can now be able to detect when owners and admins have been added or removed from the environment. AWS is another third-party app, and according to Microsoft, it is the most protected app in cloud app security today that organizations are using. No surprise there, AWS, used by many organizations, Fortune 100 and on down. Many have migrated the entire data centers and their applications into AWS, and so because of that, it's housing very sensitive information. So of course, that's something that you would want to protect. MCAS can detect S3 bucket activities and allow an admin to create policies around that. You might have heard in a lot of these breaches, an S3 bucket was left publicly available, exposed, and was left like that for weeks, months at a time, and no one noticing, because there was nobody looking, right? There was no tool to govern that access to be alerted, be notified that, hey, there's an S3 bucket out there that should not be publicly available. Well, MCAS allows you to build those rules, build those policies to detect when they're publicly accessible, right? So some of the built-in template, as you notice here, those cloud trail changes, console sign-in failures, EC2 instance changes, and network gateway changes. And finally, the third-party app is Google Workspace. This connector has been, I believe, was one of the original 5 or 6 that were available within Cloud App Security. So it's pretty robust. As you notice here within Google Workspace, there's a lot of flexibility and ways to apply controls and govern that data. So this is just a sample of a policy that can be created. You notice all the different options you have here. If files are being uploaded, make sure that they're marked private, being able to apply labels to them. Removing public access, reducing that public access, a lot of different options you have here, and all because that app has been connected to Cloud App Security. Number 3 is leverage your conditional access app control policies. So this is a slide you may have seen before. It's been around for a little while, but it's basically just showing how conditional access is that policy engine. And when working with Cloud App Security, you have a real powerful tool. You have a way to get that visibility into the, not only get the visibility, but also control access to those applications as well. Some example scenarios, preventing data exfiltration, right? Blocking that download, cut, copy, and printing of sensitive documents on unmanaged devices. Applying protection on download, right? So instead of blocking, you have a policy that says if you download this document, it has to be, an information protection label must be applied to it that is highly confidential because of the type of data that was found in it. Preventing upload of unlabeled files, right? So making sure that users are not just uploading content to the environment without ensuring that it is properly labeled. Blocking potential malware in the environment. So if someone tries to upload or accidentally is uploading malware, that can be a policy that's blocked, and those are generally enabled by default. Monitoring user sessions for compliance, right? Risky users are monitored when they sign into apps, and their actions are logged from within the session. And it gives you the ability to investigate and analyze that behavior to understand where and under what condition session policy should be applied in the future. And we'll have a quick demo of that to show you. And then there's, of course, block access and being able to block custom activities. Just some restrictions that may apply or that do apply when setting up applications. So this goes back to what I mentioned before. We have those 17 apps that have API connectivity. MCAS can protect any application using these session protocols. The caveat is they need to be web-based apps that support SAML 2.0 or OpenID Connect. And if they're on-prem applications, they are being reverse proxied by Azure App Proxy or the secure hybrid access providers that are part of the secure hybrid access ecosystem. You can also use this with other identity providers, right? So it doesn't have to be Azure AD. If you have another identity provider in your environment, you can leverage this functionality as well. Just a quick overview of how that works. So this is assuming Azure Active Directory is your IDP, Box is your third-party application, user signs in. It's a an analysis because that application box is behind that session proxy. But there are some policies like protect downloads from managed devices with AIP, monitor and alert actions when user activity is suspicious, enforce read-only mode, right? So all these policies can be evaluated, and then if it seems good, the user is granted access. If there's a violation, then the user is blocked. So let me just give a quick demonstration here. And I'm going to momentarily pause my screen. What I have here is a conditional access policy in this environment. So you can just see here, it's called CASB policy 0365. I have one user specified, it's Allison, and two apps, 0365 here and SharePoint, but really everything would fall under 0365. And then I have the session control using a custom policy that's using a conditional access app control. If I go over to Cloud App Security and look at my under Investigate, I'll make sure my screen is visible. Jackie, if you're there and you can see my screen, can you just give me a confirmation? Okay, thanks.
You're
good. So under my conditional access app control apps policies, I have a policy for Teams. Now I'm going to use Teams because that's what I have in my environment, my lab environment here. I don't have a Box account. But there's that app because I've signed in to this environment. It shows up here as a connected app, as you notice here. Under policies, under control, if I go to conditional access, I have a policy that says, let's just take a look at it. So it's based off a template, the block, cut, copy, and paste based on real time. And here are my filters. So it is going to, if the activity is a cut copy item and the app equals Microsoft Teams and the device is not Intune compliant, hybrid Azure AD joined, or using a valid client certificate, then I want to block that activity. There's other things you can do here. You can even do some content inspection. So you can turn this on and do further matching. So if there's specific data, let's say it's PII data, financial data, other data that you may be governed by regulation, you can enable that. We won't do that for our purposes here, but you can block that access. So let me, let me log out here and start from scratch. I'm going to go to an incognito and in private window here, and I'm going to log in as this user under Teams. And I want you to notice the first thing. Sorry, I have to get the password. Okay. So the first thing you notice here is you look at the URL. Now, because I have this session control policy in place, I am being routed through the Cloud App Security proxy. Users will get this message. This is something that can be hidden administratively, or me as a user, I can hide this notification for 1 week. But it basically tells the users access to Microsoft Teams is being monitored. I click continue. And let's say within this team here, I want to try to copy and paste this because I want to, this is IP and I'm going to steal it and take it to my next employer. Well, first you notice that my ability to right click copy paste is not there. So I'm going to try to do Control C on my keyboard. And what happens? That action is blocked because of that policy, right? So just one example of the features and abilities that you have within the environment to protect that sensitive data that you have in your environment by using these session control policies. Let's go back to our presentation. Okay, so you should be back at the deck. There was my demo. The second to last way is leveraging DLP, Microsoft Information Protection, and MCAS together. This is likely, it could be a whole separate webinar unto itself, but real quick, essentially, MCAS is part of a platform of offerings, right? On the left, you have the user productivity tools with O365 and its constituent components, endpoint DLP that you can enable. Of course, it's now Azure Purview for that data governance, and the MCAS in integrating with those third-party SaaS applications. But you can now scope policies to MCAS apps. So within the Microsoft compliance, so compliance.microsoft.com, that portal, which is where you would set up all your information governance, information protection, your sensitive information types. You can create DLP policies that will now flow to Cloud App Security, and again, give you that unified, converged experience. You notice here in the screen capture here, there is a slider now for Microsoft Cloud App Security when choosing where to apply those policies. Again, this feature, generally available. Now that is a one-directional transfer. So the rule of thumb is when creating DLP policies, you should always start in compliance portal, compliance.microsoft.com, and apply those policies to where you want them. This could be any of the workloads, Exchange, SharePoint, OneDrive, Teams, and now, of course, Cloud App Security. And you can even also do this for restricted third-party apps. Again, so you get that unified capability in the environment. Benefits of doing that, right? You're protecting your files and your data in the cloud. With those API-based app connectors, you get that full visibility. Now you're able to apply DLP policies to them. If you haven't yet, you leverage information protection for data classification and labeling. Strongly encourage you to do so. Talk to us. We are equipped to help our customers get off the ground with those data protection and data governance type projects. But really want to start applying those policies, those labels to your data assets so that you can start building more robust controls over them. As an example, again, with a third-party app like Box, you can create an activity policy that in Box, watermarks are how Box labels documents. So you can create a policy that will apply a particular watermark to a document within Box, right? Because you have that integration, and now you have that unified DLP experience. Same with GitHub, different activity, different feature you can apply. But again, because you have that integration, you're able to use those same policies. And we talked about the Slack scenario before. And the final step, because see I'm running out of time here, is you want to operationalize MCAS. Very simply, make MCAS a key part of your SOC toolset. Again, I've been at customers, they have it available, they have some integration, but they haven't operationalized it. There's nobody looking at it. So it's gathering all this great information, it's throwing up alerts that someone should be looking at, but they just have not incorporated it as part of their tool set. If you have the resources, assign one or more analysts to make it part of their daily task to review those alerts, review the activity log, right? Start doing that correlation, closing some of those alerts within the environment so that you have that audit trail. And of course, keep up to date with the roadmap and the changes. And some resources, so I mentioned this before at the outset, but there are some resources for those third-party integrations. There's a whole MCAS Ninja training that's available online in the tech community. Of course, there's the webinars, and then there's, I mentioned that app governance piece there. That's also available online as part of the Microsoft documentation, where you can go and get more information about that. I see there are no questions, so thank you for joining us today. If you do have any questions, feel free to reach out. Here's my contact information, and we look forward to seeing you at our next webinar.